When you look at the wind, you may think of it as something simple air moving around us, invisible but always present. But in reality, wind is one of the most powerful and constant forces on our planet. It is a result of the uneven heating of Earth's surface by the sun. Oceans, deserts, mountains, and forests all absorb and release heat differently. Warm air rises, cooler air sinks, and the constant exchange of these air masses creates pressure differences. Nature always tries to equalize these differences, and this equalization is what we feel as wind. In other words, wind is solar energy transformed into motion. Scientists estimate that about 2% of the total solar radiation that reaches Earth becomes kinetic energy of moving air. At first glance, 2% may sound tiny. But if you realize how much energy the sun sends to Earth every day, even 2% is an astronomical amount, far more than all the energy consumed by humanity combined. Wind is not random chaos. There are global patterns shaped by Earth's rotation and the Coriolis effect, creating trade winds, jet streams, and monsoons. There are also local winds influenced by mountains, valleys, and coastlines. Together, they form a dynamic system that never rests. Humans learned to use this force thousands of years ago. The very first sailing ships harnessed wind to travel across oceans. Ancient Persians built the first vertical axis windmills over 1,500 years ago, grinding grain and pumping water. In Europe, windmills became iconic, especially in the Netherlands, where they literally shaped the landscape by draining water and creating farmland. But today, the purpose of wind technology has changed. Instead of grinding wheat or pumping water, we use wind to create electricity. Modern wind turbines are the descendants of those ancient mills, but instead of simple wooden sails, they are advanced machines made of steel, composites, electronics, and computer systems. The principle, however, remains simple. The wind pushes against the blades of the turbine. These blades are shaped like airplane wings, designed according to aerodynamics. Air moving around the blades creates lift, a force that makes the rotor turn. The rotor drives a shaft, transferring mechanical energy to a generator. The generator transforms that motion into electricity. It sounds straightforward. Wind turns blades, blades turn a generator, electricity is created. But behind this simple idea lies decades of research and one of the most complex engineering challenges ever. Modern turbines can be enormous. Offshore turbines today reach 250 meters in height, with blades longer than 100 meters. To imagine that, each blade is as long as a football field. Why so big? Because the energy captured by a turbine grows with the swept area of the rotor. The larger the circle that the blades sweep through, the more wind energy is harvested. A single giant turbine can now power tens of thousands of homes. But there is a problem. The wind is not constant. Sometimes it's calm, sometimes too strong, sometimes just right. Engineers had to solve this challenge by designing turbines with advanced control systems. Turbines automatically adjust the angle of their blades, rotate to face the wind, and even shut down if conditions become too extreme. And so, wind has transformed from something human, feared or ignored, into one of the main pillars of renewable energy. From a distance, a wind turbine may look simple, a tall white tower with 3 long blades slowly turning in the sky. But that elegant shape hides one of the most advanced machines ever created by humanity. A modern wind turbine is a masterpiece of engineering, part airplane, part power plant, part supercomputer. To understand how it works, let's go step by step through every part. The tower, the foundation of power, the tower is the backbone of the turbine. It holds the nacelle and blades high above the ground or sea, where the wind is stronger and less turbulent. The taller the tower, the more consistent the wind flow. That's why modern turbines often rise 100 to 150 meters, and offshore giants can exceed 200 meters. Inside the tower is not just empty space. Technicians climb ladders or take small elevators to reach the nacelle at the top. Thick cables run down the tower carrying electricity from the generator to the transformer at the base. The tower must be extremely strong, yet slightly flexible, able to withstand storms, lightning, and even hurricanes. The nacelle, the heart and brain. At the very top sits the nacelle, a massive capsule that houses the critical components of the turbine. If the tower is the body, the nacelle is the brain and heart. Inside it we find the main shaft, connected directly to the rotor blades. The gearbox, which increases the speed of rotation. The rotor spins slowly, usually only 10 to 20 revolutions per minute. But the generator needs hundreds or thousands of revolutions to produce electricity efficiently. The gearbox bridges this gap. The generator, which transforms mechanical rotation into electricity using electromagnetic induction. Cooling and lubrication systems, ensuring everything runs smoothly and does not overheat. The nacelle is also mounted on a rotating system called the yaw drive. Sensors constantly measure wind direction, and powerful motors rotate the entire nacelle so the blades always face the wind. Without this, a turbine would capture only a fraction of the available energy. The blades' giant wings in the sky. The blades are the most visible part of a turbine, and they are feats of aerodynamics. Each blade can be over 100 meters long and weighs many tons, yet is perfectly balanced. They are shaped like airplane wings, curved on one side, flatter on the other. When wind flows over them, a pressure difference is created, generating lift. This lift force pulls the blades around, turning the rotor. The materials used are high-tech composites, often fiberglass or carbon fiber reinforced plastics. They must be light yet strong enough to withstand decades of stress, rain, ice, and even lightning strikes. Each blade can also rotate on its own axis. This is known as pitch control. By adjusting the angle, the turbine can capture more or less energy. In low winds, blades are angled to catch every bit of force. In strong winds, they are turned slightly to reduce stress. In extreme winds, blades turn almost parallel to the wind, preventing dangerous overloads. This ability to adapt is what makes modern turbines so efficient and safe. The generator turning motion into electricity. Once the rotor spins the shaft, the energy must be converted into electricity. The generator does this using the principle of electromagnetic induction. When magnets spin near coils of wire, they push electrons and create an electric current. Some turbines use asynchronous generators, simpler and cheaper. Others use synchronous permanent magnet generators, more efficient but also more expensive. Regardless of type, the result is the same: clean electricity. The control systems, a turbine's nervous system. A turbine isn't just mechanical, it is a fully automated system. Computers monitor every aspect: wind speed, wind direction, rotor speed, vibrations, temperature, and more. If the wind becomes dangerously strong, usually above 25 meters per second, the turbine automatically shuts down to protect itself. If vibrations rise above safe levels, brakes can stop the rotor in seconds. This automation allows wind turbines to run almost entirely without human intervention, producing electricity day and night, in summer and winter. Electrical connection. From the blades to the grid, the electricity generated travels down the tower through thick cables to a transformer, which adjusts the voltage. From there, it enters the electrical grid. In a wind farm, dozens or even hundreds of turbines are connected together, feeding massive amounts of clean electricity into national networks. Safety systems. Built to survive, wind turbines face some of the harshest conditions on Earth. Storms, freezing temperatures, lightning, and salt water can all damage equipment. That's why they are filled with safety systems. Brakes on the main shaft to stop the rotor in emergencies. Fire suppression systems inside the nacelle. Lightning protection systems in the blades. Vibration sensors that can detect even the smallest imbalance. Every part of the turbine is designed to last 20 to 25 years, with minimal downtime. Today, most of the electricity consumed worldwide still comes from fossil fuels, coal, oil, and natural gas. These sources have powered industry and modern life for more than a century, but they come at a heavy price. They are finite, and their emissions drive climate change on a global scale. That is why renewable energy is not just an option anymore. It has become a necessity. And among all renewable sources, wind stands out as one of the most promising. The global rise of wind energy, wind power, is no longer a niche technology. It is now a mainstream part of the global energy system. Countries all over the world are building wind farms, both on land and at sea. China, the United States, and the European Union are the current leaders, with hundreds of gigawatts already installed. In Denmark, more than 40% of all electricity comes from wind. In Spain and Ireland, the numbers are close behind. Globally, the installed wind capacity has surpassed 900 gigawatts, and it continues to grow every year. To put that in perspective, that's equivalent to the capacity of hundreds of nuclear power plants. Offshore wind. A new frontier, one of the most exciting developments is the rise of offshore wind farms. These are giant turbines built out at sea, where winds are stronger and more consistent. Offshore turbines are true giants, some reaching 250 meters in height, with blades longer than 100 meters. One such turbine can power tens of thousands of homes by itself. And the innovation does not stop there. Engineers are developing floating wind turbines, anchored in deep oceans with cables and moorings. These can be deployed in places where the water is too deep for traditional towers. Floating wind opens up vast new areas of the planet to clean energy, solving the problem of intermittency. The biggest challenge of wind power is that the wind does not blow all the time. Some days it's strong, other days calm. How can we ensure a stable power supply? The answer lies in a combination of technologies, smart grids that balance supply and demand in real time, battery storage systems that save excess energy when the wind is strong and release it when it is weak, hybrid solutions where wind is combined with solar, hydropower, or hydrogen production. For example, when the wind is strong at night, turbines can produce electricity that is used to generate green hydrogen, a fuel that can power industries, vehicles, and even airplanes. In this way, wind energy is not just electricity. It becomes part of a broader energy revolution. Economic power of the wind. Another reason for optimism is cost. Over the last few decades, the price of wind energy has fallen dramatically. In many countries, wind is now the cheapest source of new electricity. Cheaper than coal, cheaper than gas, and even cheaper than solar in some cases. This makes wind not only an environmental solution, but also an economic one. For governments and businesses, building wind farms is often the most cost-effective way to expand their power supply. Environmental benefits and concerns. Wind power produces electricity without burning fuel, without releasing carbon dioxide, and without polluting the air. Over its lifetime, a turbine produces dozens of times more energy than it takes to build it. In less than a year of operation, a turbine repays its energy debt. After that, it is pure, clean power for decades. There are concerns, of course. Wind farms can affect landscapes and be seen as visually intrusive. Turbines generate low-frequency noise, and their spinning blades can pose risks to birds and bats. Offshore farms can have some impact on marine ecosystems. But innovation is addressing these problems. Blade recycling technologies are being developed. Quieter and more efficient designs are being introduced. Careful planning reduces harm to wildlife. In short, the technology is becoming smarter, cleaner, and more sustainable every year. A vision of the future. Imagine standing on the coast and seeing the horizon filled with massive wind turbines, each as tall as ASCII scraper, their blades turning slowly in the wind. Imagine those turbines powering entire nations, sending clean electricity into homes, schools, hospitals, and industries. Imagine storing the excess energy in giant batteries or turning it into hydrogen fuel to power ships and airplanes. This vision is not science fiction. It is already happening. Countries like the UK and Germany are building massive offshore wind farms. Japan and Norway are testing floating turbines in deep waters. The technology is advancing faster than most people realize. By 2050, experts predict that wind could supply 1/3 of the world's electricity. Combined with solar and other renewables, it could replace fossil fuels entirely. That would mean not only reducing greenhouse gas emissions, but also creating millions of jobs, lowering electricity costs, and giving humanity a chance to fight climate change effectively.